systems and the client server systems. Okay, and we started the virtual machine based operating system also. That is this one. Okay, VM virtual machine is a one single physical machine. Virtual machine is a single physical machine. That machine can run many other virtual machines. Virtual machines, underline. Okay. Single actual machine, that means physical machine, can run more number of virtual machines in it. Okay. Each of which that virtual machine will appear like it is a complete machine. Okay. So that is virtual machine. Can you hear me clearly, students? Students, I said for the class test, I will give the questions. Okay. So that I will give you today, now in the lecture itself. Okay. So you don't think about that. Now you listen. Okay. So
okay,
the last operating system structure is virtual machine. Okay. Virtual machine is a single physical machine, can run many virtual machines in it. When it is running many virtual machines, each virtual machine will be appeared as a complete machine. That means we cannot find any difference between the actual machine and the virtual machine. Okay. What is the use of this? Users can run any software on any operating system. Think about this. You have one application. Okay, you want to open that application in a Windows operating system, and then you want to work on the same application using Linux operating system. Okay, both will be supported. So then you will experience what is the difference between two operating systems. Okay, if all the application you could use in a different operating system, you will understand the platform of all those operating systems. And also each and every operating system has its own merits. Okay, of course, demerits also. So you can, for example, you are working in a company and you want to keep your database, you want to access your database in highly protected, highly secured way. Then you can access that in a Linux operating system. Okay, because Linux will give high security. So like that, the operating system will have its own advantage. You can experience the same usage of the same application in different operating system platform. Okay. So that is the ultimate use of the virtual machine. And more than that, suppose you want to work on more number of operating system, you no need to buy, you no need to keep a separate machine for that. Even if you did partition also, the performance degradation would be there. Okay. So all these you can avoid. Okay. Here how if suppose when you are using 3 virtual machines, that means 3 operating systems. Okay. Any one of the operating system at a time you will use, at that time the entire system property will be used by only that operating system. That means it will act as only that operating system is there in your machine. Okay. So that is the advantage. Okay. There is no memory partition. For example, one operating system ke liye only this much memory. For another operating system, the another set of memory is in. Okay. So entire resources of the machine will be used by the currently active operating system. Okay, currently active operating system. Okay, so that is the advantage. Okay, there are two types of oh Rama, you go and speak slowly. थोड़ा inside वो अंदर ये okay Chalo, chalo. Wait. Okay. So there are two hypervisors. Sorry. Mm. So how you can switch between one operating system to another operating system? Very easily you can switch if you use virtual machine. You have to just enter inside the virtual machine. That's it. So after that, you can select the operating system. Okay, now the switching between the operating system will be done by another layer of software, which is called a hypervisor. See in the diagram it is mentioned, look at here, type 1 hypervisor, type 2 hypervisor. Okay, so this is also software. Okay, this is also software. So this software will be helpful to switch between different virtual machines. Okay, which is nothing but to switch between different operating systems. Okay. So there are two types of virtual machines based on the hypervisor, based on the type of hypervisor. Okay, there are two different virtual machines. One is type 1 hypervisor VM virtual machine. Another one is type 2 hypervisor virtual machine. Type 1 hypervisor virtual machine, type 2 hypervisor virtual machine. Okay. Now, what is type 1 hypervisor virtual machine? In type 1 hypervisor virtual machine, look at here, this is type 1. Look at the diagram, all of you. This is type 1 hypervisor. Okay, based virtual machine. You can imagine below this, all the in these two models, the bottommost would be the hardware. Bottommost here it is not mentioned, but you can imagine the bottommost is hardware. Bottommost is hardware. Okay. So, if you look at the type 1 hypervisor, there is no any host operating system, which is native operating system. There is no host operating system. Okay. Directly on the hardware, the type 1 hypervisor software will be loaded. I said in the bottommost you have to imagine what? Hardware. Okay. Already see, whenever you are imagining, whenever you think about the operating system is the interface between the hardware and the user. You know that. Okay. So here the hardware would be there. Directly on the hardware, the type 1 hypervisor will be loaded. That means not on the hardware. The first layer which can directly access the hardware is called type 1 hypervisor. Okay. Usually how it would be, suppose if virtual machine is not there, hypervisor is not there. Immediately just above the hardware, operating system will be there, isn't it? But here, immediately after the hardware, that means just above the hardware, which is nothing but very close to hardware, which will be there, type 1 hypervisor software will be there. Okay. On the type 1 hypervisor software, there are any number of, suppose you want to load 3 operating systems. So, on the type, keeping the type 1 hypervisor as a base, on that, the other operating systems will be loaded. Okay. So, in this type of virtual machine, there is no different privilege for each operating system. All the operating system will be treated in same level. All the operating systems will be treated in same level. That's why here all the operating systems are called guest operating systems. None of the operating system is a host, H-O-S-T, host operating system. All the operating systems are guest operating systems. There is no difference in priority of the operating systems here. All the operating systems are equal. Okay. So on the operating system, there are many applications. Okay. Now by switching the operating system, you can use any application. Here the dot dot, it denotes any other operating system also you can load. Here they have shown only 2, Windows and Linux. So and so on. Okay. So that is the type 1 hypervisor. Simply on type 1 hypervisor, on the hardware, the type 1 hypervisor software will be loaded. On the type 1 hypervisor software, keeping the type 1 hypervisor software as a base, operating systems will be loaded. Plural, operating systems will be loaded. Okay. Here, this type of operating system is called as bare metal operating system. Bare metal. That means here directly on the hardware, the hypervisor is loaded. Okay. So this is type 1 hypervisor. Whereas in type 2 hypervisor, below to all I said there is a hardware. On the hardware there will be one operating system. Okay. So this is the host operating system. This will be the host operating system. That means this is the actual native operating system of the system, of this machine. Okay. So on the host operating system, the type 2 hypervisor will be loaded. Okay. And on the type 2 hypervisor, there are one or more guest operating systems will be loaded. Okay. Of course, the host operating system will have its own applications. These applications, whatever you are loaded on the host operating system, that you can use in this operating system only. Okay. So these are the applications. These are the user applications, which are directly loaded on the host operating system. Could be this is very highly secured applications or very important applications that could be there here. Okay. Suppose now this is like in your machine. For example, in your machine already you have one operating system as a native operating system. Okay. Now you want to load the virtual machine, you will load the type 2 hypervisor software, and then you can on that you can load the guest operating system. So here there are hierarchy. That means the priority of the operating system is different. Okay. One operating system, which is host operating system, has high priority than other guest operating system. Here only two classification of operating system. Host operating system and guest operating system. Here nothing like that. All the operating systems are guest operating systems. Okay. So this is about the virtual machine. Okay. Now example of type 1 hypervisor. We have IBB VM/CMS. That is the first type 1 hypervisor based operating system. Okay, VM, simply called VM. VM denotes virtual machine. Okay, VM/CMS. It's Microsoft product. Okay, VM/CMS. VM/CMS. Everything capital. Okay, VM/CMS is a type 1 hypervisor virtual machine, and there are many other virtual machines also. For example, VMware, that is another type of virtual machine. ESX, okay, that is another type 1 virtual machine. Microsoft's Hyper-V, okay, Hyper, HYPER, Hyper/V, letter V, okay. So this is also this will also come under what? Type 1 hypervisor. Okay. Type 2 hypervisor. Examples for type 2 hypervisors are Wait a second. Oracle VMware. Okay, Oracle VMware. That is the example for, there are others also. There are other type 2 hypervisor also. Okay. But I remember that only now because we used in our lab, we used Oracle. Okay, Oracle VMware and vWare Fusion. Okay, vWare Fusion. That is another type 2 hypervisor. And VM Virtual Box. VM Virtual Box. That is another hypervisor. Type 2 hypervisor. Okay, Oracle Solaris. Oracle Solaris also another type 2 hypervisor. Okay, so Oracle VMware, Oracle VMware, VMware WARE, ware. Okay, VMware, that's a single word. Okay, Oracle VMware, that is one example for type 2 hypervisor. Another is VMware Fusion. VMware Fusion. Okay. Then we have Oracle Solaris. Okay. Oracle Solaris. Then we have VM Virtual Box. VM Virtual Box. All these are examples for type 2 hypervisor. Okay. Now, before starting the process creation and process deletion and different states of process, I just tell you what are the questions. Answer for which questions you have to study for internal class test of operating system. Okay, please note down. Question number 1. Question number 1. Just wait. First, what is operating system? What is operating system? Okay, what is an operating system? Okay. So you will say operating system is interface between so and so. Okay. Then in your, as per your textbook, inside the what is operating system only, they have given the operating system as an extended machine. The operating system as an extended machine, and the point 2, the operating system as a resource manager. Okay. Because you can't define when one particular thing is used by users, 2 different type of users. You can't give one definition. You can't give one definition. Okay. So when I am saying any market statistics, okay, something like that, then you have to define. When I am asking to define anything related to market, okay, how will you define? You have to ask how I have to define. Okay, how I have to define, because in customer's perspective the market is different. Okay, the supplier's perspective the market is different. So there are different category of users. So definition also in which perspective it should be. Okay, like that here operating system is, or systems are used by the end users. That means the us users, application users, and also it is used by the hardware. Okay, So in hardware's perspective, the operating system is different than the user's perspective, isn't it? So that under what is operating system, there are two topics given in your book itself. Okay, one is it is an interface, that is generic. Another one, the operating system is a resource manager. To whom? To the hardware. For the hardware, operating system is a resource manager. Okay. Okay. For the end users, operating system is an extended machine. Operating system is an extended machine. Okay. So these two you have to study. I may ask, explain how the operating system is an extended machine. Okay. Or I may ask, explain how the operating system is a resource manager. Okay. Noted? Okay. Next main topic
yes,
is...
But ma'am, the exam would be MCQ or short
MCQ.
answer?
I know it is MCQ. Yeah. But MCQs as a question bank I will not give. Okay. You have to study this. Okay. A descriptive type question answer you have to study. Then inside that only I will ask the objective type question. You will be able to answer. Okay. Okay. So you study like this only, because this will be helpful when you give the semester exam. Okay. Okay. Semester exam anyway it is going to be offline. Okay. So you study like this. Okay. And then next topic is history of operating system. Main topic is history of operating system. In that, in history of operating system, you will study about the different generation of operating system. Okay. Already I said this I did not take as lecture. Okay. This if you go through in every generation how the operating system evolved, that you will understand. Okay. In the first generation is this is just a theory go through. Okay, first generation is 1945 to 55. Vacuum tubes are the main materials had been used during that time. Okay, in the systems. And then the second generation is between 1955 to 65. In that generation only transistors were started to use to build the system. And the processing, the type of the processing was introduced. That type is batch processing system. You know what is batch processing system? We already discussed. Okay. So in second generation, transistors and batch processing system were introduced. Okay. And then in the third generation is between 1965 to 1980. Here only we started to use chip ICs, okay, integrated circuits, okay, and the multi-programming concepts came here only. Here only a single system में, in single machine में, क्या जो आप बार-बार छुट्टी Okay. So third generation 1965 to 1980 ICs, integrated circuits and multi-programming concepts were introduced that time. Here only that multi-programming, multi-processing, for example, one machine will be used. In one machine you can use more than one applications at a time. Okay, that was possible from this era only, in this generation only. Okay. Fourth generation only the personal computers, very compact computers, which will support multiprocessing and also networking. Okay, so that is the fourth generation computers. Here they have given more, you just go through. Okay, just read it, it is enough. Now whatever I said about the generation, the year, and what was newly introduced, that is only important. Okay.
Ma'am,
Yes.
ma'am, can you tell me the year gap of fourth generation?
Fourth generation. It is there in your book, but still I'll tell you. Fourth generation 1980 and till present 1980.
Okay. And ma'am, can you repeat the first generation, please? I was noting it down. I just missed
Okay,
that part.
okay, no problem. Wait. Second generation you asked, no? First generation. First generation 1945 to 55. 45 to 55.
Okay.
1945 to 55.
And ma'am, under that?
Or not. Vacuum tubes, no? It's a material which are made up of glass. Okay. So we did not use transistors that time. Okay. We used only vacuum tubes. Vacuum tubes is a complete, it's kind of tube only, but it is completely made of glass material. Because glass is good conductor, no? So heat will be conductor. And later that so now in this, when we used vacuum tubes only, to keep a single server, single system, we need a entire room. Okay, big space is required because the system will be, computing system will be that big. Because each and every cell, every material is made up of vacuum tube. Okay, so it occupied more space and all. Okay, Babbage's computer you would have heard, that is this only. Okay, so that is 1945 to 55. And then second generation 55 to 65. Or you can take there it is 55, now 56 to 65. Okay. So 55 to 1955 to 65, transistors and batch systems were introduced. During batch systems only the magnetic tape and all be used. In one system now we are using, we will give the input, the output processing will be done inside the processor, and then output Ria please vena pannada, let it be na nee sorry students. In your class, how many of you are Tamilian? Attending the lectures, being at home is difficult for you and for me also. And especially small children are there, no? Yeah. And in front of us, they are doing anything wrongly, no? We will get disturbed. We cannot completely concentrate on what we are doing. Huh? There are so many. Dhanapriya, Saima, okay. Nagapushpam, Shubha, Vignesh, Mahalakshmi, Shivaraman, Harish. Harish is to Lakshmi. Okay, so many. Ishwar. One day we will talk in Tamil. Okay. Others will fight with me or quarrel with me. What to do? So where we left? I'm saying questions. No, I started to teach. Okay. So first generation, second generation, third generation, fourth generation. Okay. Okay. After the generations, that is history of operating system. But history of, you may wonder, history of operating systems may they said about the evolution of systems, computers. No. Because the operating system is completely based on the architecture of the system. Okay. So that's what. Then next topic, computer hardware review. Okay. In computer hardware review, I may ask about explain processors. Remember, what is CPU and CPU cycle. Okay. We discussed now CPU cycle, fetch, decode, fetch, decode, execute. Okay. These three are called different steps in a CPU cycle. Okay, I may ask what is decode also. Decode. During fetching, what may happen and all. Okay. Yes. What did you ask?
In offline lecture, how much mark will come? Like what is processor? For how much mark it will come?
See, I can take a question either 1 mark or 2 mark. Okay, 2 marks only. Objective type only I can ask. Okay. Okay.
Okay, ma'am.
I may ask fill in the blanks. Okay. Don't expect that MCQs only I will give. I may, one second, let me think. Match the following I can give. Okay. I can give match the following. 5 left side options, set of options. Right side may there are set of options. You have to match. Okay. Correct option with the right side option. Okay. You know, match the following. So I may give match the following. I may give true or false. Okay. I may give fill in the blanks, but for fill in the blanks also, I have to give 4 options. Minimum 4 options down. Okay. So then that is also MCQs, no? Okay. So see, fill in the blanks may, generally fill in the blanks, matlab options will not be given, no? But I have to, it is a rule, I have to give the options. Okay. So MCQs, then you can take that as a MCQ. So multiple choice questions can come, true or false, match the following. This you can expect. This is, I am saying, only for operating system. Only for operating system. Okay.
Ma'am, the question bank you are giving right now, if we refer that, it will be helpful, right? For the MCQ based questions, like for this 20 marks.
It is enough. It is enough. You no need to.
Okay,
yes. Even
ma'am, she was asking about offline exams.
Also from these chapters, not from this portion what I am giving. No, for the, only those questions. If you refer, that is enough. No other question will. Okay. So processors, under the processor, what you have to study, what is CPU and CPU cycle. And remember, we discussed about the pipelining, superscalar pipelining. Okay, there are 2 diagrams in your book. Okay, 3-stage pipeline and superscalar CPU. So that you should study. Explanation of that also. What is superscalar? You have to study. And then you just go through multi-core chips. That is also there. Multi-threaded is there that you don't see because threading concept till now I did not teach you. Okay. Multi-core chip. That may also come under the processor. Okay. Then memory. all these I'm saying inside the hardware overview. Hardware overview में first processor, okay? Processor का अंदर even this multi-core chip also you have to go through, and then memory. Second is memory. Under the hardware overview, second component is memory. Inside the memory only we studied about the different hierarchy of memory. Why single memory is not enough, different hierarchy of memory is required. What is the difference between registers? These are memories: registers, cache, main memory, magnetic disk. Okay, magnetic tape you no need to study. It's not used. That is obsolete. Yes, yes.
Ma'am, you will not ask about the program counter or multiplexing of time and space.
Let me finish first. Let me finish. Then, if it is not come, no, whatever I am saying, then it will not. Okay.
Ma'am, can you repeat that part? You were telling that difference between this.
Registers. These are different names for memory. Okay. Denote different memory. Okay. Registers, cache, CACHE. Okay. Some people will pronounce cache memory, but the correct is cache. Okay. So cache, main memory, magnetic disk. Registers, cache, main memory, magnetic disk. Okay. Magnetic disk drawing the diagram I explained, the PPT which I shared with you know, in that it is there. So magnetic disk under whatever I taught, everything you have to study. Okay. Then different layers of cache, cache 1, L1 cache, L2 cache, that also you have to study under cache. EEPROM is given in cache, you just omit. No need to go through EEPROM. Okay. And then disk. Okay, disk separately in your textbook given. It is given. Okay, so tracks, sectors, so that cylinder, all those you have to study. Okay, read write head. Okay, rotatable arm. So all the structure you have to know. And then IO devices. Okay, after disk, no, IO devices. I am going as per your book sequence only. Okay, then only it will be easy for you when you refer your book. Okay, so under IO devices, everything whatever I taught you have to study. Okay, disk controller, disk driver. Okay, what is IO subsystem? All those. Okay, and one more important thing, inside the IO devices only, you will study programmed IO, interrupt driven IO, DMA. Programmed IO, interrupt driven IO, DMA. Okay. Now this programmed IO, interrupt driven IO, DMA, you will not study in the book PDF which I shared. Tenenbaum book mein you don't study. Diagram I shared with you. Online may it is there. Okay, so I will give the link. Wait, now itself I will give. 1 second. In the chat I will share. I have please wait.
Ma'am, can you repeat third wala again?
1 second, Kaifali, 1 second.
Okay, ma'am.
See, in the chat, I have shared the link with you. Okay. So that link, inside that link, you can study about the DMA. Okay, DMA controller. Wait a second. Okay, interrupt driven IO and programmed IO you can study in the next link which I shared with you. So now what, Kaifali, what you asked?
Ma'am, third question I wanted to write again.
Third question is what? Which question? You are saying about IO devices.
Yes, ma'am.
Inside the IO devices, you will study about what is IO subsystem, device driver, device controller, then programmed IO, interrupt driven IO, DMA, direct memory access.
And ma'am, under computer hardware wala,
See, under the computer hardware, that is a main topic. Under that, there are many 4-5 topics. Okay, the first one is processor, second memory, third disk, third disks, fourth tape is given, but you don't study tape. It's not required. IO devices. All these will come under hardware overview only. Okay. So separately under hardware overview, you will not study anything. Hardware overview inside under you have processors. All those are all these are hardware in the system machine. Okay. Processor, memory, disk, and then IO devices. Okay. So all these will come under hardware overview only. Okay. Still anything? Any confusion?
Ma'am, then in offline exam they will ask like hardware overview or each
No.
term separately.
No. Because in semester exam you have maximum 6 marks. Descriptive type questions. No. Each question carries 6 marks. Either 6 or 5. Okay. So then everything I can't ask. No. Any one of the subtopics will come. I may ask about draw the disk and explain the structure of disk, or I may ask explain the processor. I may ask explain the superscalar processor and pipelining under the processor. So like that only. Okay. Everything I can't ask. Okay, but you have to study everything. Okay, anything can be asked. Anyone can be asked. And after IO processors, after IO devices, buses also there, buses. You remember I said about the address bus, data bus, signal bus. All these buses are connected with, buses are simply transmission lines, cables, channels. Okay. So buses also will come under hardware overview. After IO devices, you have to note down buses, BUSES, buses. Okay. Then next main topic is the operating system zoo. Okay. Hardware overview over. Hardware overview is completed. Next main title is the operating system zoo. Their name only they have given operating system zoo, but inside that they have given different types of operating system. Remember, mainframe operating system is the first one. Okay, then personal computer operating systems, and then handheld computer operating systems, And then server operating systems. Multiprocessor operating systems. Embedded operating systems. Sensor node operating systems. Sensor node. SENSOR. Sensor node. NODE. Sensor node operating system. Smart card operating system. Sensor node operating system. Smart card operating system. Real time operating system. All these are different types of operating system. But you should know all these can be asked as operating system zoo. Okay, in the semester exam, I can ask, explain any 3 types of operating system, or I may ask by giving the name also, explain the real-time operating system, smart card operating system, and sensor node operating system. Like that also I may ask. Okay, should I repeat this again or no? Not required. Students?
Not required, ma'am.
Okay.
नहीं वर
So all those operating systems. Okay, and then now what the current topic? Then we started main topic, operating system concepts. Okay, basic concepts of operating system. Under this, we saw process. Processor is different, process is different. Okay, we saw about processors, plural of process. Okay, processors, PROCESSES, PROCESSES, processors. Okay, and then address space. Processors, address space, and then file system. Files, that's it.
नहीं आता 13वीला
Okay,
12वीला होते
I repeat, under operating system concepts. Under operating system concepts, we studied processors. What are processors?
graduate
What is address space? Address space and files. Okay. And then we saw about what is system calls. System calls also basic operating system concepts only. Okay, system calls. By taking the read system call, we understood what is system call. Okay. And there are different category of system calls also. Process management system calls. In your textbook, page number 51, they have given the table. Process management system call, file management system call, directory management system call, miscellaneous. In that miscellaneous, you don't need to go through. Others you have to go through.
ठीक है
So system calls,
लेक्चर में है बाद में करता हूँ फोन
and then we started the structure of operating systems.
Ma'am, can you repeat system call?
System calls by taking the read system call as example, and then process management system call, file management system call, directory management system call. These three system call category they have given: process management, file management, directory management. Okay, in the same page they have given miscellaneous system calls that you don't study. No need to study. Okay. Next, operating system structure. Structure of operating systems. Okay. That is there in your book or textbook, page number 61. Okay. Operating system structure. This is the main topic, operating system structure. Inside the operating system structure, we studied monolithic, layered, microkernel, okay, client server, and now virtual machine. Okay. Under the virtual machine, they have given many things. BM7370 ka structure, virtual machine, rediscovered and all that and all you don't study. Okay. That is for those who are studying deeply about the virtual machine. That you don't go through. And exokernels also there. That and all you don't go through. Okay. That's it. Till this you study. That's enough. I said process creation and all, but process creation today I did not start, so you don't. It will not come. Okay. So till this you have to study. Okay. Anything you want to ask?
Ma'am, can you tell once again about the structure of OS, ma'am?
Structure of OS, monolithic structure. Monolithic structure. Okay, layered structure. Layered, L-A-Y-E-R-E-D, layered structure. See, remember, under layered structure, you have to refer the THE, capital letter, THE operating system, the operating system, and also multics, M-U-L-T-I-C-S, multics. These two are two different architecture of layered operating systems. Layered operating systems. Okay. The THE, the operating system, and multics, M-U-L-T-I-C-S, multics operating system. Both will come under the second category, layered operating system. Okay. So second is layered operating system. Third one, microkernel structure. Microkernel structure. Microkernel structure only by taking Minix, M-I-N-I-X. Minix operating system as example we studied. Minix. Okay, microkernel structure ka andar. Actually that is the structure. Microkernel is the structure of the operating system, but where, in which operating system this structure has been used, that is Minix. Capital letter, everything capital letter. M-I-N-I-X. Even multics also everything capital letter. M-U-L-T-I-C-S, multics. Minix, M-I-N-I-X, Minix. This is example for microkernel operating system. Okay. Next, fourth category of structure is client server. Client server structure. Okay. So it is very good to network the systems when we are using the systems in network. Okay. So client server and then VM, virtual machine. Last fifth one is virtual machine system. This is also one structure. Okay. That's it. Students, anything you want to ask? Any doubt? Tomorrow you have, which paper you have? Oops, no? You have oops tomorrow.
Yes.
Right?
Yes, ma'am.
Day after tomorrow, Wednesday?
GC.
GC. And after that you have operating system, no? Thursday, right? Okay, so see your timetable.
No, ma'am. It's on Friday.
Friday, so Thursday, what you have?
NSM.
Okay. So Friday, but anyway, before that I will take lecture, okay? But that will not come for your internals, okay? but you have to attend the lecture. Always the internals will be along with other lectures only. Lectures will not be cancelled because that is for 20 marks. No. So no this cancellation will happen. Lecture will not be cancelled. Okay. MPA lecture started now.
Yes, ma'am. It will start by 11:35. Can we leave?
Okay. Even yesterday also ma'am took, no? Yesterday, day before yesterday and all.
Yes, ma'am.
Okay, fine. Anything else from your side, students?
Ma'am, all would be come from these all only now. These all questions only will come now.
Yes. I said no already. Apart from why you are doubting so much. Apart from this, nothing else will come.
Okay, ma'am. Thank you.
Okay, fine. Thank you, students. In tomorrow's lecture, Tuesday, you have a what? I have to check. Okay. In next lecture, we will see the process creation. Actually, operating system, we are going very slow. We have to speed up. Okay. Because it is very vast. And people are saying your exam may also be there in April. So we have to rush it. Okay. So please don't waste the time. Don't waste the time. Of course, this 1 week you will not waste. You will study. But generally, I'm saying don't waste the time. You don't have any what. Later, there are many work. Your internals, all the subject ka internals, everything will come at a single time. Okay, so you will not be able to manage if you did not plan now itself. Okay. So all the subjects, whatever till date ma'am taught, you have to study and keep. Okay. Because now only you will be many lectures will be cancelled. All those will happen. Teacher will go slowly and all. Okay. So later you should not ask me, ma'am, if you rush up like this, how we can that and all. No. Okay. So hereafter, every teacher will start to go fast. So we need your cooperation. Okay, you have to come along with us. Okay. Thank you, students. You all can leave.
Thank you, ma'am. Bye.
Bye to all.
Thank you, ma'am.
Bye.
Hi, ma'am.